Hello everyone. We are at the final stage of learning the basics of PyTorch, and we are ready to optimize the model parameters. So the objective is to validate and test our model by optimizing its parameters. I hope these things are clear to you now. This is neural network and this is data loader, which is a kind of wrapper. This is data set, so it has a lot of data sets like fashion MNIST data sets from torch vision, and these are the transform. So we are going to import all of this. Then this is the loop which we have already learned, so I will not go into the details, just go through it fast. So this is how we get the training data, this is how we get the test data. We wrap them in a data loader, and then we build a neural network here, we build a model here. So that is how this works. And then next part is hyperparameter tuning. So there are three hyperparameters. One is number of epochs, which you can take 5, 10, 20, 30 depending on how many are required for convergence. Then there is batch size. We are taking a batch size of 64. The recommendation is that the batch size should not be very low or very high. That will not work properly. You can experiment with the batch size. And then there is learning rate. Again, learning rate should be not very low and not very high. A very low learning rate will uh, slow the training process, and very high learning rate is even worse, it will give you uh, uncertain results. So these are the hyperparameters. And then during every epoch we will do two steps. First step is we will train the loop. We will run a train loop in which we will train the model, and we will validate whether the training has improved the performance or not. These two things will be done in every epoch. And then something about the training process. The training process is an iterative process, and in training process, in every epoch, the model makes a guess about the output, and the loss function calculates the loss using that output and the actual output. And then derivatives are calculated with respect to parameters. And then an optimizer like gradient descent is used to uh, backpropagate the derivatives and optimize or modify the parameters. So this is how the training process work. I hope the theory of deep learning is clear to you. This is nothing new, I'm just repeating it. Then something about backpropagation. There are three steps we have to perform in backpropagation. First is, in backpropagation, whatever gradient was calculated in the previous epoch, the gradients tend to add up to the previous gradients. So if you add up to the previous gradient, you may get wrong result. That is why it is important to make the gradient 0 before you start backpropagation. So the first step is making the gradient 0. Second step is this loss backwards. This will calculate the derivatives and gradients. And then the third step is optimizer dot step. It will adjust or modify the parameter. So these three steps are required during the backpropagation. This is the training, this is a function which runs the training loop, and this is a function which runs the test loop. I will come back here in a second, but before that let me explain this. So here the loss function used is cross entropy, and the optimizer used is SGD, stochastic gradient descent. Instead of this SGD, you can use RMS prob, AdaGrad, AdaDelta, Adam. There are so many. So any of them you can experiment with them and check which one gives the best result. We are going to run 10 epochs. So this for loop will run for 10 times, and in every for loop which will call the train loop and it will call the test loop, and the code for train and test loop is given in the above cell. So in every epoch it will train the model, and immediately in the test loop it will check whether the performance of model has improved due to training or not. So that is how it works. So in every loop, in every epoch, we will train and check if the performance has improved or not. So if you understood this, I will run this, and it has started training, and it will take some time. In the meanwhile, let me explain the train loop. So in the train loop, the first thing to check is the size. So size is actually the total number of records in the data set. So for fashion MNIST data set, the number of records in train set are 60,000, and in test set they are 10,000. 60,000 and 10,000. So the value of size is 60,000 for fashion MNIST dataset. And now we are iterating over data loader. So when you iterate over the data loader, even in every iteration it will give you the next batch. So as a result, we will get a batch, and we will get the records, the features in the batch, and the output label. We will give the input to the model and get some prediction, and using that prediction the loss function will calculate the loss. Using that prediction and actual output, it will calculate the loss. Now that we have calculated the loss, it is time to backpropagate. So backpropagation, as I explained earlier, has got 3 steps: making the gradient 0, calculating the derivatives and gradients using loss dot backward, and then optimizing the parameters using optimizer dot step. So this is how backpropagation is performed in these 3 steps. And then after every 100 batches, we will print the accuracy and loss. This is how train loop works. Now for test loop, again we will first calculate the size, that is number of records in a data set, and then we will calculate the number of batches. So how many batches are there in that particular data loader, that we will calculate. These two variables are kept to 0 initially, and I have told you in previous tutorial that we need to calculate the gradient only during training and not during testing. So now we have to disable the gradients. We do that by using with torch dot no grad. So no gradients will be calculated. We will iterate over the data loader, get the input and output label, predict the output, calculate the loss, and this is running inside a for loop, and we have here plus equal to, that means it will accumulate the test loss for all the batches. It will accumulate the test loss for all the batches. And here we are calculating the number of correct predictions in that batches. So if the prediction of model is same as the real output, then we will sum up all the correct predictions, and that we will add to correct. Again we have plus equal to here, that means for all batches the correct predictions are accumulated. So once this for loop is over, you have addition of all the losses of all the batches and addition of all the correct predictions for all the batches. We want to divide this by number of batches to get the average test loss, because this test loss is for all the batches. So we will divide it by number of batches to get the average test loss. This correct predictions are for all the records, so we will divide it by the number of records in the data set to get the accuracy. So for example, in test set we have got 10,000 records. Out of that, if 9,000 are correct prediction, then we divide 9,000 by 10,000, so we get 0.9, which is 90% accuracy. So that is how we get correct will give us the accuracy. And so at the end we will display the accuracy and the loss. That is how it works. So I hope the working of train loop and test loop is quite clear to you. Then I hope the training is over here and you can see how it looks. So yeah, this is the first epoch. In the first epoch, it will first take the first batch. It will take the first batch and it will display the loss. It will display the loss after every 100 batches. So one batch has got 64 records, so 100 batches will have 6400 records. That is why it is 6400 here. And you can see that after first epoch the accuracy is 50.3 and loss is 2.17. Also you can see the loss goes on decreasing after every batch. After every batch the loss goes on decreasing. That has happened in the first epoch. Then in the second epoch the loss is again decreasing and accuracy has increased. So from 50 it has gone to 58 and loss has gone down from 2.17 to 1.92. In the third epoch the loss, sorry, in the third epoch the loss has again decreased, accuracy has increased 60.4. This is 63.5, this is 1.26. So after every epoch the accuracy increases and loss decreases. That is how it works. So after the end of 10 epochs what we get is accuracy of 69 and loss is 0.81. So instead of 10 epochs, if you run it for 20 epochs, 30 epochs, then you will get even more accuracy and even lesser average. So that is how due to parameter optimization, the weights and the biases values are adjusted in such a way that the model starts converging and starts giving better and better result. That is how the training happens and that is how we test the result. So I hope things are very clear. The last part is very simple, how to save the model and how to load the model. We need to import this torch hidden model dot as model and torch dot save and model dot state dictionary. It will be saved in the form of a dictionary and then we have to give the name, with what name we want to save it. So if you run this you will see that it has been saved. So I run it here and then I run the save model and you will see that the model has been saved here with this name, model weights dot path. And then if you want to load the saved model then the syntax is like this, model dot load state dictionary and then the name of the model. That is how you load the model. So this is how you save the model and this is how you load the model. I think the things are very clear to you. This was the last tutorial in this series and we have learned a lot of things here, a lot of new things here. If your deep learning basics are very clear, then what I have taught you must have been very clear to you. If you still have any doubts, please go through all the videos again. If still the doubt remains, please ask your doubt in comments. You can ask me or contact me over email or you can be in touch on LinkedIn and I have given the links in my description. So thank you, all the best, goodbye.